Greetings and welcome everyone. My name is Lokita Maka. In this session, we are going to discuss simple organic compounds. So, what are organic compounds? Generally, organic compounds are any chemical compounds that contain carbon hydrogen bonds. The study of properties, reactions, and synthesis of organic compounds comprise the discipline known as organic chemistry. Therefore, when we're talking about organic chemistry, we're talking about the chemistry of carbon. The name organic itself reflects the fact that organic molecules are derived from living organisms. They are derived from biotic components or biotic factors. There are four families of organic molecules that are grouped together as hydrocarbons. Now, before we talk about hydrocarbons, let's look at the carbon atom. How do we characterize a carbon atom? Carbon is the chemical element with the symbol C and atomic number 6. You will see this on your periodic table. It contains 6 protons in the nucleus. That's why it has the atomic number 6, right? Now, carbon is non-metallic and it is tetravalent. Now, what do we mean by that? It means that it makes 4 electrons available to form covalent chemical bonds. Now, if you look at your periodic table, you will find carbon in group 40. Now, one interesting thing is that carbon makes up only 0.025% of the Earth's crust. And most importantly, what we need to note is that this chemical element has the ability to bond with multiple elements. So now, what are hydrocarbons? Now, if you look at the hydrocarbon, this is any of a class of organic chemical compounds composed, composed of the elements carbon and hydrogen. The carbon atoms join together to form the framework of the compound. Then the hydrogen atoms attach to them in many different configurations. Hydrocarbons are the principal constituents of petroleum and natural gas. They serve as fuels and lubricants, as well as raw materials for production of plastics, fibers, rubber, solvents, explosives, and industrial chemicals. So many hydrocarbons occur in nature. In addition to making up fossil fuels, they are present in trees and plants, as for example, in the form of pigments called carotenes that occur in carrots and green leaves. Now, more than 98% of natural crude rubber is a hydrocarbon polymer that is a chain-like molecule consisting of many units linked together. The structures and chemistry of individual hydrocarbons depend in large part on the types of chemical bonds that link together the atoms of constituent molecules. So there are four families that contain molecules made up of only carbon and hydrogen. Now these are alkanes, alkenes, alkynes, and aromatics. So let's look at these families. Now, if we look at alkanes, alkanes are atoms that are joined by single bonds only and they are saturated. Now, what do we mean by saturated? We mean that a saturated hydrocarbon is a hydrocarbon in which all the carbon carbon bonds are single bonds, right? So this hydrocarbon is an organic compound whose only constituents are carbon and hydrogen. Right. Then we have alkenes. Now with alkenes, at least one carbon-carbon double bond. So it will have at least one carbon-carbon double bond, and they are unsaturated. Alkynes as well, they are unsaturated. Aromatic compounds, they are also unsaturated. Now, unsaturated hydrocarbons are hydrocarbons that have a double or triple bonds between the adjacent carbon atoms. Now, this term unsaturated means more hydrogen atoms may be added to their hydrocarbon to make it more saturated, right? Now, with alkynes, they have at least one carbon-carbon triple bond. For example, propane. Then with alkenes, an example of that will be propene. With alkanes, an example will be propane. But we will get to the naming of these in the next few minutes. Then we've got aromatic compounds, which contain a ring of alternating single and double bonds. So let's look at these hydrocarbons, these examples of these organic compounds that we are talking about. So we are going to start with alkanes. So basically, alkanes are hydrocarbons that contain only carbon-carbon single bonds, as I have mentioned previously. Now, every carbon atom participates in four single bonds, either to another carbon or to a hydrogen. Now, also, we need to note that every hydrogen atom is bonded to a carbon by a single bond. So the alkanes will have the suffix A and E at the end, but we're going to discuss that. Right. Now, this table give some examples of alkanes. There are quite a lot, from methane, ethane, propane, butane. Okay. I seem to be rhyming now. So let's look at how do we name these compounds. How do we name alkanes? So we use the International Union of Pure and Applied Chemistry. Basically, we name organic compounds using the system. We're using the rules of the system, basically. So, what are the rules? Now, in order to name organic compounds, one thing that I must encourage you, at least memorize the few basic names. So, in general, the base part of the name reflects the number of carbons in what you have assigned to be the parent chain, right? The suffix now of the name will then reflect the type of the functional group present on or within the parent chain, right? The other groups which are attached to the parent chain are called substituents. Okay. Now, the names of all alkanes, as I have mentioned, that they end with A and E. Whether or not the carbon are linked together from end to end in a ring, or which we call cyclic alkanes or cycloalkanes, or whether they contain side chains and branches, the name of every carbon hydrogen chain that lacks any double bond or functional group will then end with the suffix A and E. So, as I have mentioned, if you look at the red parts, of the names here on this table. That's why I was saying it's important to memorize the basics, the basic name, few basic names. For instance, the prefix, if that compound has got one carbon, then the prefix will be meth. Now, if it's alkane, the general rule is that the alkanes end with the suffix ane. So now if the compound has got one carbon atom, now what does that mean? Because we have said earlier carbon is tetravalent, so if it has one, then it means it can only link four hydrogen atoms, right? Now that we will call methane, right? The prefix will not change. But if it has two carbons, the prefix will be eth. Then because now we are dealing with alkanes, then the suffix will be ane. So two carbon atoms with six hydrogen atoms, then that will be ethane. Then with three carbon atoms and eight hydrogen atoms, then that compound will be a propane. So it will be meth, one carbon, eth, two carbons, prop, three carbons, bute, four carbons, pent, five carbons, hex, six carbons, hept, seven carbons, oct, eight carbons, non, nine carbons, dic, dic for decane, 10 carbons. So those are the prefixes that you can use in order to remember the naming of these compounds. Now, looking at the structural formula of alkanes. Now, alkanes with unbranched carbon chains are simply named by the number of carbon chains, right? So the first four members of the series, as I have mentioned, that they are named as, for instance, if you look at methane, which is CH4, meaning that it has one carbon atom and four hydrogen atoms, we call it methane. Therefore, there will be one hydrogen saturated carbon, right? Now, with ethane, which is C2H6, will have two hydrogen saturated carbons. CH3, which is propane, will have three hydrogen saturated carbons. With CH4, C4H10, which is butane, will have four hydrogen saturated carbons. Right. Now, alkanes with five or more carbon atoms are named by adding the suffix a and e to the appropriate numerical multiplier. Now, except the terminal a, right? Now, this which is removed from the basic numerical term. So now you will remember with mathematics you had hexagons, pentagons, all those things. Now, this is where this is derived from. So from alkanes with five or more carbons, we use the numerical multiplier, right? Hence, you will see pentane, which has got five carbons and 12 hydrogens, right? Now, hexane again, with refreshing your memory from numeracy or mathematics, then hexagon will have six sides, remember. Then we've got C7H16, which is called heptane, and so on and so forth. So alkanes in which now the carbons are connected in a straight chains are called normal alkanes, as you can see here, right? There is a straight chain of hexane. Then alkanes that are branched are called branched chain alkanes. Now, straight chains alkanes are sometimes indicated by the prefix N for to distinguish them from branched chain alkanes, having the same number of carbon atoms. Although this is not strictly necessary, the usage is still common in cases where there is an important difference in properties between the straight chain as well as the branched chain isomers. So now if you look at that isomer there, which is 2-methyl pentane, now, so we talked about isomers just now. Let's look at them. What are these? Now, molecules that do not differ in overall molecular formula that is specified by the number of atoms of each kind and the net charge, but only in the internal structure are called isomers. So these molecules will have different structures, but they will have the same molecular formula. Let me repeat it. When two or more molecules share the same molecular formula but different atomic connections, we call them constitutional isomers. Now, if you look at all these compounds here, they have 6 carbon atoms. They have 6 carbon atoms, but their structures are different. And therefore, now, based on where we find the branch, then the names will be different. For instance, we have 2-methyl pentane. Now, that 2 there represents that the branch or the first branch, or rather, because here it's the only branch, it's found on the second atom, on the second carbon atom, right? Then, now this branch on its own, because there's only one carbon there, so it's a methyl, right? Remember, I said we must memorize or know the basic prefixes, right? Which is the standard rule. So the prefix there is meth, and therefore, so this methyl is found on the second carbon atom, or it's attached on the second carbon atom. Then the remaining compounds now, or the remaining carbons, how many are they? They are 5. So now going back now to the standard naming of these compounds, the general rules, if we've got 5 carbon atoms, then the prefix will be pent. So now this gives us 2-methyl pentane, right? Then again, if we look at 2.2 dimethyl butane, now how did we name this one, or how was this one named? The branches are found, 2 of these branches, right, are found on the second carbon atom. They are attached on the second carbon atom. Now, because there are 2, we cannot say 2.2 methyl butane. Because there are 2, we will use the prefix dimethyl to indicate that there are 2 of them. And now with the straight chain, we have 4 carbon atoms, right? Now going back again to the prefix or to the naming. Now these are four carbons in a straight line, therefore it's a butane. So that's how you name it. It's the same thing with the 2,3 or 2.3 dimethyl butane. So what is the difference now with this one and the latter one? Now the first branch is attached to the second carbon, but the second branch of the same compound is attached on the third branch. So that's why now we use or we add the number 3 to indicate. So it's 2,3 dimethyl because there are two of these compounds which are the same, and there are, again, on a straight line, there are 4 carbon atoms. Now the prefix we're going to use there is a butane or but. Then because now these are alkanes, then we add this the suffix a and e. The same with the 2-methyl pentane. So you can create your own examples. Try by all means to practice this. Understand isomers. Just give yourself the molecular formula, play around isomers that you can find. Then in that way you can be able to understand isomers. Again, when we are talking about isomers, we are talking about 2 or more molecules which share the same molecular formula but have different atomic connections. The remaining 3 families of hydrocarbons are alkenes, alkynes, and aromatics, and these are unsaturated. So we have discussed saturated and unsaturated, but basically when we're talking about unsaturated, this means that they contain less than the maximum number of hydrogens per carbon. All right. Structurally, this means that they have carbon-carbon double or triple bonds. Now, let's look at alkenes. So, alkenes are unsaturated hydrocarbons containing at least one carbon-carbon double bond. Basically, they have the general formula CnH2n, right? Now with n represents the number of atoms, right? And then with the hydrogen carbons, then what will happen is we are going to multiply that number of carbons by 2. And then after, of course, after ethane, we will add another 2 after that multiplication. Okay. But don't stress about that. Now, these are named similarly to alkanes, but with the following changes. Let's look at the differences now. The naming alkenes is similar to alkanes, but now the difference there is that the alkenes will have the suffix ene. So if we have one carbon atom, then basically it will start with 2 carbon atoms, because remember we said um, it must have a double bond. So they have a double bond. So let's start with ethene, right? Ethene will have 2 carbons double bonded, and then When we are naming them now, we'll then add A and E. So sticking to the general rule, understanding the prefixes from meth, eth, prop, but, then you just add E and E depending on the number of carbon atoms. So here, because we have two carbon atoms, then the prefix we use there is eth. Then at the end, you just add the suffix ene. And how do you know that? Because you have seen the double bond. So the double bond will tell you that, okay, this is an alkene. It's not an alkane anymore, right? Then with hexene as well. Now, if you refresh your memory, going back to the previous slide, you have seen how we have done the hexane. But now we are dealing with double bonds. So now the longest chain, which is selected as a parent hydride, must include the double bond. So that is one thing you need to note. And then the suffix now, A and E from alkanes or the alkane parent name, here we replace it with the suffix ene. Now that tells us that these compounds contain double bonds. So it can be one, it can be two, it can be three double bonds. Then coming to the alkynes. Now alkynes are unsaturated as well. They contain at least one CC triple bond. One carbon-carbon triple bond. Now again, they have the general formula CnH2n minus 2 in this case, right? Now, they are named similar to alkanes as well, or to alkenes as well, but we only replacing now the A and E with Y and E. Now this represents that there is a triple bond. Now again, you must be asking yourself, now why are we subtracting two hydrogen bonds, right? Now remember, with ethane, ethane will have two carbon atoms, right? But they are, because they are single bonded, then each of these carbon can have now three hydrogen atoms, right? Making a total of 6 hydrogen atoms. But moving to alkanes now, because they are single bonded, now an ethene will now have, each carbon now will have 2 of these hydrogen. Now remember, at the beginning of our lesson, we said that the carbon atom is tetravalent, meaning that only 4, it can make 4 electrons available to attach other atoms, right? So now, coming to this one, we will only have two hydrogens attached to these two carbon atoms, because there is a triple bond. I hope that makes sense. Then we've got aromatic compounds. Now, what are aromatic compounds? Now, an aromatic compound is any of the large class of unsaturated chemical compounds which is characterized by one or more planar rings of atoms joined by covalent bonds of different kinds. right? So they are often drawn to look like alkenes, but they behave much differently than alkenes. Also, they have an alternating pattern of double and single bonds within that ring, right? Now, the benzene is an example. Now, the unique stability of these compounds is referred to as aromaticity, right? Although the term aromatic originally concerned odor, today its use in chemistry is restricted to compounds that have particular electronic, structural, or chemical properties. Now, looking at benzene. Now, benzene, which is C6H6, right? Six carbon atoms as well as um, six hydrogen atoms. But now, again, if you look at one of these carbon atoms, remember we said it is tetravalent, so there are about four bonds there, right? So there's a double bond that links a carbon to another carbon, then only single bonds linking the hydrogens. Right. So benzene is the best known aromatic compound. That's why we are using it as an example. And the parent to which numerous other aromatic compounds are related. Now, the six carbons of benzene are joined in a ring having a planar geometry of a regular hexagon, in which all of the carbon-carbon bond distances are equal. Naming aromatic compounds isn't quite so straightforward as naming chain compounds. Now, often more than one name is acceptable, and it's not uncommon to find old names which are still in use as well. Now, these aromatic compounds or naming of these compounds are based on benzene, which is C6H6, which has a ring of six carbon atoms and has a symbol. So each corner of the hexagon has got a carbon atom with a hydrogen atom attached, right? Now let's look at methyl benzene, right? Now this is another obvious name that the benzene has a methyl group attached to it, right? Now other alkyne side chain would be named similarly for example, an ethyl benzene. Now the old name for methyl benzene is toluene. So you may still, when you are doing your reading, you can still find that. Now let's look at alcohols, carboxylic acids, and esters. Now, in addition to these four families of hydrocarbons, there are also many families of organic molecules. So the hydrocarbons we've talked about are not the only families of organic compounds or organic molecules. Now we also have alcohols, we have carboxylic acids, we have esters, we also have ethers, thiols. There are many of them. Right? Now, these other families include elements other than carbon and hydrogen. So they will include other elements like oxygen, like nitrogen, phosphorus, and some. So they will include some of the other elements. So remember, we are only discussing hydrocarbons, but now we also want to look at some of the compounds that contain hydrogen and carbon, but also other elements. Right. Now, the families are distinguished by a group of atoms called the functional group. So now when we're talking about a functional group, now this is an atom or a group of atoms that are bond that gives a molecule a particular set of chemical or physical properties. Now let's look at alcohols. Alcohols. Now an alcohol is an organic compound with a hydroxyl functional group. Now when we're talking about hydroxyl functional group, we are talking about an OH group, right? Because OH is the functional group of all alcohol, we often now represent alcohols by the general formula ROH. Now, where R is an alkyl group. Now, this is not new to most people because most people are familiar with alcohols. They are common in nature. Most people are familiar with ethyl alcohol, for instance, ethanol, which is the active ingredient in alcoholic beverages. Even if you don't consume in alcoholic beverages, but you must be familiar with this. But this compound is the only one of a family of organic compounds known as alcohols, right? It's not the only one. Now, the family also includes um such familiar substances as cholesterols and carbohydrates. Now, also, methanol and ethanol are the first two members of the homogeneous or homologous series. Sorry for that series of alcohols. So I'll make time where I can make another session just on these separate groups now, these functional groups. Right. So remember, we said that now alcohols are the members of alcohol family. They contain a hydroxyl group. They are represented now by OH. Now, if you look at this diagram, which at this formula for ethanol, at the structure, so the prefix there is eth because it has two carbon atoms, but now because there is an addition now of the hydroxyl group, which is OH, right? Now the naming will now be different. Now the alcohols will end with OL. Now the suffix for alcohols will be OL, ethanol, methanol, butanol, and so on and so forth. Then we've got carboxylic acids. Now, a carboxylic acid is an organic acid that contains a carboxyl group. So remember, with alcohols, we said they contain hydroxyl groups, right? Now, with the carboxyl groups, now COOH will be attached now to the alkyl group. So now the general formula, because we said that we represent alkyls with the symbol R, then the general formula will be RCOOH or RCO2H, with R referring to the alkyl, of course, or alkenyl, or even aryl, or any other groups, right? Now, carboxylic acids occur widely. Now, these are also familiar to most people. Now, one of the important examples, they are found in the amino acids as well as fatty acids. Now, the most common carboxylic acids that I think we know or we are familiar about, for example, formic acid. Now, formic acid contains only one carbon atom, and therefore the IUPAC name would be therefore methanoic acid. Now, how do we represent this? It will be um, HCOOH, right? Then we have ethanoic acid, which the common name for that is acetic acid. Now, this contains two carbon atoms, and mostly it's used in, or it's found in vinegars. Then with methanoic acids, mostly insect stings. When the insect stings us, that's when we get methanoic acid. And then we've got propanoic acid, which has got three carbon atom, and this is usually a preservative for stored grains, body odor, milk, butter, and cheese. Then we have butanoic acid. The common name is butyric acid, which has got four carbon atoms, and it's mostly found in butter. Now, let's talk about esters. Now, when we're talking about an ester, this is any of a class of organic compounds that react with water to produce alcohols and organic or inorganic acids, right? So, esters are derived from carboxylic acids. So, this is the most common, right? So, they react with carboxylic acids. They generally can be synthesized by reacting a carboxylic acid with an alcohol, right? So they also react with water to produce alcohols. Okay, fine. Now the names of esters are derived from parent alcohol and an acid. For example, now as the ester formed by ethanol and ethanoic acid is called or is known as ethyl ethanoate, right? Now that ethanol is reduced now to ethyl, while the ethanoic acid from the carboxylic acid now group is now reduced to ethanoate, right? That's how we get the name. For instance, if you look at the one on the screen, now the carboxylic acid there's a carboxylic acid, there's also an alcohol now, which gives us an ester, then water, right? So now we have ethyl propanoate. Where is it derived from? Now take few minutes to think about that. Remember, we said that an ethanol and ethanoic acid is known as ethyl ethanoate. Now, where this ethanol is changed or reduced to ethyl, while ethanoic acid is reduced to ethanoate. So now we have ethyl propanoate on the screen. So think about it. So ethyl propanoate will be derived from ethanol and propanoic acid, right? Then a methyl propanoate, for example, will be derived from a methanol and propanoic acid, and a butyl octanoate, for example, will be therefore derived from butane and octanoic acid. So take your time, play around these, because the name of, for instance, if we take ethyl ethanoate, that name is derived from components from which it is synthesized. Now, for example, as I have mentioned, ethanol and ethanoic acid. So now find time, play around these words, play around your formulas, um, add carboxylic acid and alcohol, see what you are getting. Um, Play around it. As a student, work around that. Now, coming to the last slide, or the last discussion, the characteristics of alcohols. Now, another distinguishing characteristic of many of these families is odor. Now, your nose is actually a highly sensitive chemical detector. That's when you get to detect all these chemicals, right? Now, the members of different families can interact differently with the receptors in your nose to produce smells that are characteristics of the families they belong to. For example, um, carboxylic acids, they produce a pungent, sometimes unpleasant odors associated with dry cheese, rancid butter, even vomit, right? However, esters on the other side, they produce a sweet, often pleasant, um, and they are mostly associated with flowers, perfumes, and various natural and artificial flavorings. All right, so please do go through this recording, repeat as many times as you can. Understand, go through the internet, understand these groups from alkanes, alkenes, alkynes, um, as well as the aromatic hydrocarbons. Then also read more on the alcohols, on carboxylic acids, on esters. Take your time, read more on that, so that you can understand, so that you can have an understanding and not be frustrated when you now have to name the compound or draw the structure, because you need to understand the basic rule. Now, the basic rule we have discussed earlier, using the IUPAC naming system. So go back to that, understand it, and if you have any questions, please do let me know. If you have any comments, if you want to add anything, any inputs are welcome, so please do let me know, leave your comments. um, Otherwise, that brings us to the end of our session. Thank you so much for joining me. Until next time.